Hello there, here is Jia and welcome to my HW3 Q2 presentation. In this question, random variable x is uniform in A to B, and random variable y equal to x squared. And the first problem is to find and draw x density function of x and random variable x mass function of x. We already know the distribution of random variety x is uniform in A to B, so we can just write down the density function like this. When x is between A to B, it's just equal to 1 divided by B minus A, and in otherwise is 0. Now we have the density function. We can use the definition of mass function to get this equation. Mass function equal to the integral of density function. So we can get this. When x less than A, it is 0. When x is between A and B, the mass function is 1 divided by B minus A times x minus A, which is actually linear function. And when x bigger than B, the mass function is just 1. Okay, now we finish the first problem. The second problem gives A equal to -1 and B equal to 3. We need to use this value to find and draw random variable y, probability density function and mass function on y. And we also need to find the expectation of random variable y. So now we know the A and B. We should put them in the x density and mass function first. So we get this. And because the x is uniform between A and B, and y is x squared, so at A squared, which is 1, and B squared, which is 9, it must be the key points. Now we know that y mass function is equal to probability random variable y less than or equal to y. Put the y equal to x squared in this function, so we can finally get this. So this is the y mass function equation. Now we can put different y in this function. For y less than 0, the mass function is 0 because this two term always 0. The y can't be actually the square root of y can't be the negative. And when y is between 0 and 1, we can calculate this equation, and the final result is the half of square root y. And when y is between 1 and 9, we can also put in this this equation. We can see the first term is 1 divided by 4, or we say 1/4 times square root y plus 1. And the second term is 0. So we can get the final result. And for y bigger than 9, the mass function is 1, of course. Similarly, random variable y density function is equal to the x density function divided by the absolute value of the derivation of deterministic function. So this is the formula like above. For y less than 0, it is 0. For y between 0 and 1, it is 1 divided by 4 times a square root 1. For y between 1 and 9, it is 1 divided by 8 times square root y. When bigger than 9, it is 0. Actually, the key point, or we say the key rules, key method of this question is two equation or two function. It's this one and this one. This one is named fundamental theorem. Okay, now we get this y density function and y mass function. We need to calculate the last one, the expectation of random variable y. We can also use the definition of the expectation. So we just calculate the sum of y times the density function in different place. So we put in these values, and we finally get the result is 7/3. Okay, this question is done. Thanks for your watching.